In the evolving landscape of global military aviation, few aircraft capture as much attention as the Tupolev Tu-160, a massive, supersonic strategic bomber designed during the final years of the Cold War. Known in NATO reporting as the Blackjack, this aircraft represents one of the most ambitious bomber programs ever undertaken. With its sleek, variable geometry wings and immense payload capacity, the Tu-160 was conceived not just as a tool of deterrence, but as a symbol of technological power. Today, decades after its first flight, the Tu-160 is reappearing in international headlines, this time in the context of renewed production. Russian officials have announced plans to produce modernized variants. The Tu-160M and Tu-160M2, in significant numbers. These announcements have raised a series of technical, economic, and strategic questions that extend far beyond national borders. What does mass production truly mean in this context? Can the industrial infrastructure that once built these bombers be fully restored? And how might this affect the strategic balance in an increasingly multipolar world? In this video, we will take a closer look at the aircraft itself, the modernization program, the reality behind production claims, and the broader implications of this development. The goal is not to take sides, but to analyze the facts and explore possible scenarios. The original Tu-160 entered service in the late 1980s as a high-speed, long-range strategic bomber capable of carrying both conventional and nuclear weapons. It remains the largest and fastest bomber ever built, capable of reaching speeds of over Mach 2 at high altitude. With a combat range exceeding 12,000 kilometers without refueling, the Tu-160 can strike targets across continents. Its maximum payload capacity is around 45,000 kilograms, allowing it to carry a variety of munitions, including free-fall bombs and long-range cruise missiles. The aircraft's variable sweep wings enable both high-speed dash capability and efficient subsonic cruising, while its 4 and K-32 afterburning turbofan engines remain among the most powerful ever installed on a combat aircraft. For decades, only a small number of Tu-160s were produced, fewer than 40 airframes in total, and even fewer remain operational today. In recent years, however, Russia has launched an ambitious modernization program aimed at upgrading existing aircraft and restarting production lines. The Tu-160M and Tu-160M2 variants are at the center of this effort. The modernization includes new avionics, navigation systems, and onboard electronics designed to replace outdated Soviet-era components. The aircraft is being equipped to carry updated long-range cruise missiles such as the KH-101 and KH-102, which are reportedly capable of striking targets at distances of 4,500 to 5,500 kilometers. This gives the platform a renewed role in long-range precision strike missions, potentially without the need to enter heavily defended airspace. Official statements have described the Tu-160M2 as almost a new aircraft, with modernized flight control systems, glass cockpits, digital communication suites, and more efficient engines. Test flights of upgraded airframes began in the late 2010s, with the first newly built Tu-160M making its maiden flight in early 2022. Russian authorities have since claimed that mass production is underway, a phrase that has been met with both interest and skepticism abroad. Understanding these claims requires distinguishing between different types of information. Official announcements often emphasize ambitious targets, including the delivery of several new aircraft per year and long-term procurement plans for dozens of bombers. Open-source intelligence, including satellite imagery and independent defense reporting, provides partial but sometimes conflicting insights. Analysts have noted that the pace of actual production appears to be gradual, with significant emphasis still on upgrading existing airframes rather than producing entirely new ones at scale. Public discourse, particularly on social media and in defense forums, tends to amplify these announcements, sometimes framing them as evidence of rapid military expansion. But the industrial reality is more complex. The original Tu-160 production line was located in Kazan, in the Republic of Tatarstan. After the collapse of the Soviet Union, the facilities were largely mothballed, and critical supply chains were disrupted. To revive production decades later, Russia has had to rebuild this industrial base almost from scratch. The Kazan Aviation Plant, or KAPO, has been undergoing extensive modernization to support this goal. New tooling, specialized equipment, and workforce training have been required to manufacture large titanium components, complex wing structures, and advanced engines. The financial scale of this effort is considerable, with reports indicating investments worth several $billion over multiple years. Re-establishing production for such a technologically demanding bomber is far more challenging than producing simpler aircraft. Beyond industrial challenges, there are economic and logistical hurdles. Strategic bombers are expensive not only to build but also to operate. Each Tu-160 requires extensive maintenance, specialized ground infrastructure, and trained personnel. Producing multiple airframes annually would demand a steady flow of high-quality materials, reliable engine production, and consistent funding, all under conditions of increasing economic pressure. Logistical bottlenecks, such as shortages of certain high-performance components or delays in subcontractor work, can easily slow the program. Technically, building new Nk-32 engines is itself a major undertaking. These engines, originally developed in the 1980s, had to be brought back into production through a separate modernization project. Any difficulties in engine manufacturing can have cascading effects on the overall production timeline. Strategically, the decision to resume Tu-160 production carries symbolic weight. The bomber represents not only a military capability but also a statement of industrial and geopolitical ambition. In theory, if production were to reach a truly large scale, for example, delivering several dozen new aircraft within a decade, it could significantly expand Russia's long-range strike capacity. This, in turn, could influence how other nations plan their own strategic forces. But several questions arise. What does mass production actually mean in a modern context where building even a few complex bombers per year is a significant achievement? How sustainable is this effort over the long term, given the economic and technical challenges involved? And how might other countries respond if a larger Tu-160 fleet becomes operational in the coming years? One possible scenario is that the production program succeeds in delivering a small but steady number of aircraft, modernizing the fleet and modestly expanding it over time. This could reinforce Russia's existing strategic bomber force without dramatically altering the global balance of power. Another, more ambitious scenario is that production accelerates significantly, leading to a much larger fleet. If that happens, neighboring powers and strategic competitors may feel compelled to adapt their air defense systems, nuclear postures, or bomber programs accordingly. There is also a signaling dimension. Strategic bombers are often used not in combat but in exercises, patrols, and demonstrations of presence. Flying Tu-160s near international airspace, for example, can serve political as well as military purposes. For Russia, reintroducing the Tu-160M2 could be a way to project strength, maintain deterrence, and reinforce its status as one of the few countries capable of producing large strategic bombers in the 21st century. At the same time, it's worth noting that other countries are modernizing their own bomber fleets. The United States is introducing the B-21 Raider, while China continues to develop its H-20 project. In this broader context, the Tu-160 program is part of a wider global trend, the revival and modernization of long-range strike capabilities, despite the end of the Cold War decades ago. The story of the Tu-160's return to production is more than a tale of one aircraft. It is a window into how nations manage legacy systems, rebuild industrial capacity, and signal strategic intentions in an uncertain world. The aircraft's raw capabilities, speed, range, and payload, remain impressive even by modern standards. But the real test lies in whether the ambitious plans for the Tu-160M and Tu-160M2 can be realized in practice. Will the Kazan plant achieve the sustained production levels needed to match official targets? Can the economic and logistical challenges be overcome? And if large numbers of modernized Tu-160s do take to the skies, how might that shape global military planning in the decades ahead? These are questions with no easy answers. What is clear is that the Tu-160 remains both a powerful machine and a potent symbol. Its resurgence illustrates how technology, strategy, and national ambition intersect, sometimes decades after an aircraft's original design. As this program develops, the world will be watching closely, analyzing not just the number of bombers produced, but the broader strategic signals they send.